right, so today we were talking about going from standard form to slope-intercept form. Now, in the years past, I've taught my students how to convert to standard form, but I don't think that that's necessary. I think what my biggest focus is showing you guys the different types of equations you're going to see, and then convincing you how to get them to slope-intercept form. Now, I think tomorrow, once we go over graphing, I think you will understand all of slope together. I think we'll all come full circle and you'll be like, oh, okay, I get this. But today we're going to focus on the last form you can see. We have point slope, which was yesterday, and today is standard. Now, standard form, again, is on your star chart. So I'll just show Addison and Charger since they're so close right here. It says standard form, and it says it's AX plus BY equals C. So I'd like you to write that form, or this equation, AX plus BY equals C. Okay? Now, theoretically, what this is saying is that this is a coefficient attached to the value of x plus a coefficient attached to the value of y equal to a number without a variable. Okay? Again, lots of different variables right here. I understand that. So I'm going to give you an example of what this looks like. 1x plus 5y equals 5. So the a is my 1, the x is my x, the b is my 5, the y is my y, and the c is equal to 5. So I want you to see right now, because I'm just showing you an example of what standard form looks like. Now, up to this point in my class, we can only solve for one variable at a time. Can we agree with that? Yes. Meaning that having an x and a y in this problem right here, there's no way we could ever solve for both of them at the exact same time. That will come later in this class. We're not there yet. But based off of this particular equation, I can convert this to slope-intercept form. So let me rewrite this problem a little bit larger. So if I have x plus 5y equals 5, can anybody put that into slope-intercept form for me? Charger?
You want to subtract the x
Okay.
on both sides?
Okay, pause right there for me. I'm going to subtract the x from both sides. Does anybody have any issues with what Charger just did? No. All he did was just literally move the x to the opposing side. Unit 1, right? Yeah. Okay. Am I in slope-intercept form yet?
No.
Why am I not in slope-intercept form yet? Colin?
Because there's the 5 is still attached to the y.
Yeah. Now, I know that I've oftentimes phrased it just like Colin did. It's attached to y. But let's think about what this is actually implying. 5 times y. Well, I understand that 5 is not that large of a number, but if you guys ever played a video game and you get that 5 times multiplier, or any number multiplier, doesn't that raise your score really quickly? If you get 10 points with a 5 times multiplier, that's really 50 points. That's a game changer. So essentially, if this y is equal to 1,000, well, now I'm changing it to 5,000, which is a really quick jump. We don't want that. Let's go back to the Texas Rangers game yesterday. If at the end of that problem, I had your grand total at like $200, and you multiplied it by 5, well, $1,000 is a lot of money spent at a Rangers game. 200, still a lot of money, but pretty reasonably priced. Does that make sense? So we don't want to multiply our y by 5. So how do I get rid of that 5? Divide everything by 5. We get y is equal to a negative 1 over 5x plus 1. Okay, so I can tell you where you guys' brains are right now. You want to know, how did I get from negative x divided by 5 to negative 1 over 5x? What do you think, Zoe?
Oh, I was going to say because in front of the variable there's like that 1.
Correct?
So,
Yeah.
yeah.
It literally just happens. Like, I didn't do anything crazy. I just put the numbers together. That's all I did. What's up, Charger?
So like, whenever like I subtract the x, I like do be 5y equals 5 minus x. That's fine, right?
So here's what Charger's saying. He's getting I'll just write it over. 5y equals 5 minus x. I agree it's the same thing. Can we agree with it? It's the same thing? It makes no difference. But can anybody think of a reason why I don't want to put it the way Charger's telling me to do it? Like, just why do we want to get our brains to think that way? Addison?
Because the way the slope intercept form is set up, it's y equals mx
Yep.
plus b, so the x needs to go.
Yep. So Charger, you're not wrong. And you could do it that way, and I will never, ever, ever count it wrong. But as I go to graphing tomorrow, I don't want you to get confused and think that this is your slope and that's your y-intercept. So I think understanding that we're going y equals mx plus b will just make it easier on you. What's up, Katie?
I'm still not sure how you got 1 over negative y over 5.
Do you agree, Katie, that there is this imaginary 1 here in front of the x? So essentially, this problem, they mean the exact same thing. All I do is I just shifted the x to the right as I wrote it to make it look neater for you. I didn't change anything. Like, I didn't...
Technically, you could do negative x over 5.
Yeah, if you wanted to. You absolutely could.
Why is it plus 1?
Why is it what?
Oh, no.
Okay. What are we thinking? Other questions? These are good questions. All right, let's move on to the next one. So like I said, in years past, I've taught people how to convert these. We're going to try teaching less to get you guys built up a little bit better. Okay, so 3x plus 2y equals 4. Once again, we're going to have ax plus by equals c. Are we okay with how this is in standard form? Okay. Can I convert this standard form to slope-intercept form? Okay. What do I do first? Luke, what do I do first?
Subtract the 3x.
Good. Subtract 3x. Let me with 2y equals negative 3x plus 4. Okay. What do I do next? Prime. Divide everything by 2. 2, 2, 2. Y equals negative 3 over 2x plus 2. Okay, still feeling pretty good about it? Are we understanding at this point that slope-intercept form really is what we're always trying to work towards? Are we starting to feel better about that? Understand that this is what we are trying to get everything to be. Tomorrow, when I show you how to graph, I promise you, it's all going to come together. But what I want you to be comfortable with is every time we're dealing with slope, can you give me this equation? The only two ways you're going to get it are either going to be in point slope form, which we talked about yesterday, and standard form, which we're talking about right now. That's it. Okay? Hey, what's up, Brian? The point slope form? We could. That's what I'm going to try to overlook this year, is how to convert to each one. We absolutely could. And if you guys really want to see how I can show you, I'm not going to do it today, but just to give you an idea. What is this right here, Brian? This is 2, right? So do we agree that this is our y-intercept? So do we have a point already given to us with our y-intercept? What would this point be? 0, 2, right? So I guess I'll just show you now that we're talking about it. So we agree that the point is 0, 2. And do we already have our slope as well?
Yes.
Okay, the slope is negative 3 over 2. So then it would just be y minus 2 equals negative 3 over 2 parentheses x minus 0. Did you see that? One thing I want you to understand is that when you have slope-intercept form, you always have a point. What point do you always have no matter what? Your y-intercept. It's always going to be 0 and then that number for your y. No matter where you're at, you always have a point, which means you can always put it in point slope form. Okay? It's a great question, Brian. I appreciate you bringing it up. Let's do one more. I'm going to jump to question number 10 at the bottom here, just because throughout notes they usually get harder as we go. So we've done 1 and 2. Now let's try this one. 7x minus y equals 4. All right, somebody raise their hand and tell me, what do I need to do first? Carter, what do I do?
Add 1y, or, no, minus 7x.
Minus 7x. It's not a bad answer, Carter, but remember we're trying to get y by itself. So now I've got negative y equals negative 7x plus 4. Okay. I know you can all tell me that we're not done yet because there's a negative in front of that y. Okay, I know you can all recognize that. There's no reason that I just randomly throw a negative in front of the y and say, okay, this is it. But now, can anybody tell me what do we need to do? If you were in my class last year, we talked about this. Katie, what do you think? Yeah, divide by a negative 1. Can anybody tell me why dividing by a negative 1 is the correct answer here? Steven, what do you think?
Because it's technically -1y, so if you divide it by -1 divided by -1 is just 1y.
Agreed. Do we agree that there's this imaginary negative 1 in front of this y? And if we think back to 6th grade, you guys have the triangle. You guys remember this triangle?
Yeah.
And a negative divided by a negative produces a positive. So when I divide negative 1 by negative 1, I never change the value. I just get a y that is alone. And then all that does is it just changes up the rest of the problem by making this become y equals 7x minus 4. Which again, slope and y-intercept. Are we okay with that? All right. I'm going to go ahead and stop talking about it. I think that you guys